We now determine whether this limit exists or not. So first I'm going to do the direct substitution. So I'm going to substitute x equals -1 into this expression. So therefore this becomes -1 quantity squared plus 3 under the root minus 2 divided by -1 plus 1. So this gives -1 quantity square is 1 and 1 plus 3 is 4. Square root of 4 is 2. So therefore this becomes 2 minus 2 divided by 0, and this gives 0 over 0. Basically this is an indeterminate form, and when we get the indeterminate form we choose a different method. So here I'm going to choose the conjugate method. In this method, we multiply the numerator and denominator by the conjugate of an expression which has a radical term in it. So clearly we can see that the numerator expression has a radical term in it. So I'm going to multiply the numerator and denominator by the conjugate of this expression. So therefore the limit will become, we have this limit of x approaches -1, x squared plus 3 under the root minus 2 divided by x plus 1. I multiply by the conjugate of this expression. The conjugate of this expression is x squared plus 3 under the root plus 2. So we multiply, as plus we divide. So therefore we have to multiply the same expression in the denominator. And in the next step, I'm going to multiply these two expressions, that is the numerator expression as plus the denominator expression. So when we do that, we get limit of x approaches -1. Notice that we can apply the difference of squares formula here. This looks like a minus b times of a plus b. So therefore, when you multiply these two, it is basically equivalent to a squared minus of b squared, where a is square root of x plus 3 and b is 2. So I'm going to use this here. So therefore, I can rewrite this as x squared plus 3 square root quantity squared minus of b is 2. So therefore, this becomes 2 squared, and divided by, here I'm not multiplying, I'm just simply uh, multiplying like this, x squared plus 3 under the root plus 2. So now we can simplify the numerator expression. So when you square the square root of quantity square, so this becomes the square root and this square will go off. So basically this we can simplify this expression. So this becomes x plus 3 minus 2 square is 4, and in fact this is x squared plus 3 minus of 4. So this becomes x squared minus 1. And once again, if we use the difference of squares, this will become x plus 1 times of x minus 1. So I'm going to replace the numerator expression as this quantity, that is x plus 1 times of x minus 1. So therefore this limit becomes limit x approaches -1, x plus 1 times of x minus 1 over x plus 1 times of x squared plus 3 under the root plus 2. We now see that we can cancel this expression x plus 1 with x plus 1 in the numerator. So finally we have the limit simplified to limit of x approaches -1. The numerator expression is reduced to x minus 1 divided by the denominator expression is x squared plus 3 under the root plus 2. We can now do the substitution when x approaches -1. So therefore this becomes -1 minus 1 divided by -1 quantity square plus 3 under the root plus 2. So we have numerator as -2 divided by this one is -1 quantity square is 1, and plus 3 is 4. So and square root of 4 is 2. We then add 2 with this, so 2 plus 2 is 4. So basically the denominator is 4. So this reduces to negative half. Therefore the value of the limit is negative half, which means the limit exists.